Alright, now that we know what iptables is and why it matters, let's dive into how it actually built. Because if you don't understand the basic structure, iptables can feel really confusing. At the heart of iptables, there are three key building blocks you need to know: tables, chains, and rules. Let's start with tables. You can think of a table as a category or a group of rules designed for a specific purpose. Each table handles a different type of network task. Here are the most common tables you'll see. Filter. This is the default table. It's all about deciding whether to allow or block traffic. NAT. This handles network address translation, basically changing IP addresses in packets. Useful for stuff like internet sharing. Mangle. This one is for modifying packets, like changing headers or marking packets for special treatment. Raw. This table is used for packets before they even go through connection tracking. Now, connection tracking is basically Linux keeping track of ongoing conversations, like remembering which packets belong to which connection. There are a few others, but these are the main ones you'll work with 99% of the time. So that's tables, big categories that serve different purposes. Now, inside each table, we have something called chains. Chains are basically a list of rules. When a packet comes into your system, it passes through these chains, and each rule inside gets a chance to inspect it and decide what to do. You can think of chains like checkpoints at an airport. There are some default chains that you'll see in almost every setup. Input handles packets destined for the local system. Output deals with packets originating from the local system. And forward manages packets that are passing through the system, typically when the machine is acting as a router or gateway. If you're using the NAT table, you'll also see chains like pre-routing and post-routing, but don't worry about those just yet. We'll cover them later when we get to NAT. And finally, inside each chain, you have rules. Rules are where the real action happens. Each rule is like a simple if this then that decision. For example, if a packet comes from this IP address, drop it. If a packet is distant for this port, allow it. If a packet is part of an existing connection, accept it. Every iptables rule has two main parts: a set of matches and a target. The matches are the conditions that decide whether the rule applies to a packet, and the target is what action to take if the matches are satisfied. The most important matches are dash dash source or dash s, match on a source IP address or network, dash dash destination or dash d, match on a destination IP address or network, dash dash protocol or dash p, match on an IP value, dash dash in dash interface or dash I, input interface, for example ETH0, dash dash out dash interface or dash o, output interface, dash dash state, match on a set of connection states, dash dash string, match on a sequence of application layer data bytes, dash dash comment, associate up to 256 bytes of comment data with a rule within kernel memory. Targets can be things like accept, allow the packet to proceed; drop, silently discard the packet without informing the sender; reject, block the packet and notify the sender with an error response. Notice here the difference between drop and reject. This is important because some people have issues differentiating these two targets. They both discard packets, but reject notify the sender and drop does not. So please remember this difference. And next, log. record packet details to system logs for analysis or troubleshooting. Now, here's something really important to understand about how IP tables process packets. Each packet is evaluated sequentially against a rule in a chain. That means the packet goes through the rules one by one, from top to bottom. And here's the key. As soon as the packet matches a rule, meaning it meets all the conditions or matches, the action is immediately taken, and no further rules in that chain are checked. It's like walking down a hallway full of doors. At each door, you check, does this door match me? If not, you move to the next door. But the moment you find a matching door, boom, you either enter, get redirected, or blocked. You stop checking any more doors after that. This behavior is called first match wins. So, the order of your rules really matters. If you put a very broad rule near the top, it might catch packets before they ever reach the more specific rules below. That's why when we build firewalls later, we'll think carefully about the sequence of our rules. Alright, let's do a quick recap. Tables group rules based on their purpose, filter, net, manipulation, etc. Chains define the path a packet takes within a table, and rules set the conditions and actions for each packet. So the basic packet flow looks like this: table, chain, rules, action. That's the basic flow.